Good evening, dear participants. Greetings from Decode Life. Myself is Parveen. I welcome you all on session 5 of this Genes to Pathways second edition workshop. We have today with us Honorable Rohmatul Faria, who is currently working as a lecturer at Statistics Department, University of Islam, Indonesia. She is working there since 1996. Also, she has responsibility of Vice Dean of Resources at Faculty of Mathematics and Natural Sciences at the same university. Her expertise area include statistics, bioinformatics, modeling and estimation, and R programming. So, with these words, now I am handing over session to Dr. Rahmatul. Over to you, ma'am.
Okay. Thank you very much, Parveen, for nice introductions. I really appreciate that. Good evening, everyone. My name is Rohmatul Fajriah, as already been introduced by Parveen. I'm working at Statistics Department at Universitas Islam Indonesia in Yogyakarta, which is in Indonesia. Currently, I'm being a vice dean, has been mentioned as well by Parveen. So today I would like to share my knowledge, which is about introduction to bioconductor. There are two parts. The first one is about microarray data analysis, which is for today. And then the second one, probably tomorrow, as I already been informed by Parveen. I also would like to apologize because yesterday I couldn't come up as already been appointed because there are something that I have to do. Okay, let's start our sharing. So this one is about bioconductor and it will be with R. So first thing, I would like to introduce you. Perhaps maybe some of you already been understand about these bioconductors, and also maybe some of you are still new to these bioconductors. So first one, I would like to introduce about what is bioconductor about. Okay, so the bioconductors actually is the repository for bioinformatics softwares. This is under R community, which is using R programming language. And I also learned that previously you already learned about R with other professors. So I hope based on the basic of R, you already been learned last 2 weeks maybe. You can also follow the introduction about these bioconductors. Okay, so if you haven't known about these bioconductors, there is the website about this bioconductor, which is www.bioconductor.org. So you can also just click in there. In this bioconductor, there are some software, there are some information about the material related to bioconductor or bioinformatics. And also there are some support sites, which is you can, how to say that, you can join with them. And if you have some question related to bioconductor software or bioinformatics by using R, you can ask some expert in there. There are many experts in there. During my study, PhD study, I also asked some question in there as well. Okay. This website about bioconductor, you can just open it, which is I already mentioned about www.bioconductor.org. Okay, you can see from here that there is information about how to install bioconductor in your computer or laptop, and then there is some help. There are also some developer because there are some package, so there are some developer as well in there for developer side. And then there is some material. They are also using R, not R, I mean there are using this bioconductor as information about some courses, about how to use the package, how to analyze the data by using the bioinformatics, because there are some other software which is BioPython, but in here we are using R, so that's why in here they're called bioconductor. Okay. Later, I would like to show you by opening this bioconductor website. Okay, I already mentioned about the online support, and then you can also in here join, signing up, and then if you have some question, you just log in, and then you can post the question in here. There are many experts to answer your question. Sometime before you post the question, you can also try to find something like repository questions and answer the previous one. I guess it started from 2001. They are already been in there. So there are a lot of things going on in there from the beginning until now. So you can have some broader knowledge. This is something, the development about this bioconductor or this bioinformatics, how to say that, bioinformatics tool for analysis. Regarding the software or package, currently there are about 2,000 package. If you are opening the bioconductor, I will show you later, and then you can try to find by using search in here. So you can also try to find maybe something that's suitable for you. Okay. Now how to install bioconductor, but before we are doing installation about this bioconductor, I would like to show by opening the website. Let me show you, just wait a minute. Okay, now I already opened it and I would like to share that with you. Okay, so here we go. This is the bioconductor website. The way how to install, there is also in here the hints how to install it step by step. We can just click in here. And then there is an information that if you are installing this bioconductor and previously you have to install the R the R software. If you already been installed the R software, and then you can also install it in R Studio as well. Okay. So first thing first, you have to install this R. The latest one, the better maybe, but it depends on what kind of analysis you would like to done. So that's why it doesn't have to be the latest one. And then when you are installing the bioconductor package, there are two kinds of package. The first one is the core of bioconductors. I think when the first time you are installing this bioconductor, the core one, the core package will be installed directly. But if you are already been installed this core package, and then you are using, for example, some package of bioconductor, and then there is the hint and also the help in here, how you are doing that. For example, in here, you are using this one for the core package in bioconductor, but in here it is for some package, because in here genomic feature package and annotation DBI. Okay. And by using this bioconductor, if you would like to find some bioconductor package, and then in R, you just type this one. We can do as well later, maybe during the practice. And then if you would like to install the update to update your install bioconductor package, you are just using this one. And if you would like to upgrade your install bioconductor package, so you can use this comment. And also, if you would like to know about troubleshooting your package installation, and then you can just use this one if it is valid, so it is okay. Okay. Previously for I think for our version below 3.6, they are not using this Bioc Manager, but they are using Biocs Lite, I guess. But for someone already just use the R version after 3.6, they need to use this Bioc Manager, okay? This one, now I would like to show you another one, which is about the support side. In here, you can see that there is a support site. Just click this one, okay? And then there are a lot of things you can, for example, you would like to ask some question about Affymetrics, platform, maybe not differentially expression, I guess, something like differentially expressions, okay? So this one, there are a lot of questions in here, so okay, so you can just before you how to say post the question, and then you can just scroll through this one, and then probably some of them already been answered your question by other experts, or maybe this is something new. If it is something new and there is no archive about this one, so you can just post your question here. And also you can, wait a minute, I think I need to make it a little bit smaller. Okay. No. Just wait a minute. This is my presentation, not the right one. Wow, no, this is not the right thing. Okay. In here, for example, you need to sign up if you would like to join this support. And then you can put your email address in here. And then after that, you can get the confirmation, and then you can post, and also you can just scrolling the question and answer. Maybe this some of them suitable as well for you. Okay, so that's about the bioconductor. Let's go back to here, to this main page of this bioconductor website. In here also you can learn because there are doing some courses, which is I have been there I think twice in 2014. It is very, very convenient. I really like it. And the teacher or the lecturer, the professor also really helped me how to learn about this, about microarray data analysis, and also about RNA sequencing. Okay. Okay, this one, and then you also the learning side in here, not just some maybe some file, but also you can find some videos. You can also find some like technical report. You also can find something like a book which is already been published by this bioconductor community. Okay. So in here also, maybe you can see some for developer, okay? Because there are, I already told you that there are some many package in here. And also in here, you can see that there is MMI, which is about the Amazon machine image, and also the Docker image. In here, I think you can do some computation, which is about parallel computing, or by maybe cloud computing, I guess. You can, if it is about cloud computing, and then you can use just something like, how to say that, core computer in cloud, and then you can run maybe for example, 24 hours, 1 day, 2 days, and so on. I think as long as you need it, and then you can pay, it will be fine. Okay, now we are going back to my presentation here. Okay, this one about how to install the bioconductor. The first one I already mentioned, which is install the R, and then open R or R Studio. And then in the console, you can just type or copy this comment, which is from the website, copy paste in there. And then after that, you would like, for example, using some package. I already mentioned as well, there are some core and specific package. For the core package, you are doing this one in R or R Studio. And then for some specific package, it depends on what kind of package in here, which is what I already mentioned as well, genomic feature and then annotation DBI. Now I would like to tell you what we can do actually in this bioconductor. The first one, you can find another package. You can update, you can upgrading, and also you can recompiling your install bioconductor package. And also you can do the troubleshoot of package installation. Okay. Here, if you would like to find bioconductor package and so on, this just you need to copy it and then you just paste it into our console. It will be really convenient for you. Oh, wait a minute. No. Okay. So in bioconductor, you can do the microarray data analysis, and also you can do the sequencing analysis, because both of them are already been provided by some developer, which is, it is very, very helpful for you. Even for me, I didn't learn everything. So when someone already been provided, it will be really grateful. And then now we would like to talk about what is microarray technology. Okay. I guess you, some of you already, most of you maybe already been known about what is microarray technology, because I heard from Parveen that most of you coming from biology background, but in here I'm from statistics background. So I guess some of my students as well in here. So this one, this microarray technology, previously in my knowledge, okay, previously you just can investigate some of the gene in one time, maybe just several genes, but by using this microarray technology, and then you can also maybe 100 or 100,000 to investigate about gene at the same time. Okay, so this microarray technology is very, very powerful. It really helps some people to understand what's going on inside our body. Okay, and also, for example, maybe something related to lineage about me and also about my family, something like that. And then this microarray technology, it can be divided into two parts. The first one is oligo technology. And the second one, we can say it is sequencing. And then for this oligo, the most not powerful, I think the most popular is Affymetrix and Illumina. And for the sequencing, we will talk about perhaps tomorrow. So for Affymetric GenShips, I think you can see on the screen, it looks like something like this. I think this is still from about 2018 until 2011, but now I think they have some other development as well. This one, okay. Affymetric is the pioneer about this platform. So this one actually containing some probe sets. After some probe set, they also getting probe. The first one is probe. The second one is probe set, which is the representative for the gene which would like to investigate. And then for this probe, in Affymetric, they have like a perfect match and also the mismatch, okay? But for Illumina, they don't have something like this in the beginning. But I think in the latest one, in the about 2012, they also introduced about this one, okay? For each probe, there are usually about 11 to 20 perfect match and then mismatch probe. And actually each probe long, it is about 25 base pair long. So this why it looks like this. If I make it zooming this technology. So this one is our chip. Okay, so this one, for example, from human, or maybe some other is from mus musculus, or maybe some other is from maybe gorilla or something like that. Okay, and then in here, this is about 500,000 cells. Okay, you can see that if we are zooming this part, and then we have this one. If you are zooming this one, we have this something like this. Okay, so this one is already been designed by the Affymetrix or the company. I'm sorry. And then if you have, for example, some sample that you would like to investigate, and then this one, actually the representative from the sample. Okay, so this one, this chip, the actual size is about 1.28 centimeter. So this is really something like nanotechnology. Okay, I already mentioned before that there is a mismatch and then there is a perfect match. The difference between perfect and mismatch is in here, which is in the middle. This is 25. So in the middle, in here, in 13. If, for example, there are C in here, maybe A will be paired with T, and then C will be paired with G. Okay. If it is C in here, maybe in mismatch, it is about T or A. Okay. So for Illumina, because they are using the bead technology, so you can say that for Illumina is Illumina bead array. So it looks like this. You can see that this is the bead, and then in here is there is information about the address. It looks like something. For example, we are as a citizen in this world. I am from Indonesia, so I will be having my passport. And then in this passport, which is my identity, okay? So this is the same thing like this. So wherever I go, as long as I have this, how to say, identity, they will now direct, for example, I'm going to India, or maybe I'm going to Malaysia. They will now direct me that actually I'm coming from Indonesia. And also other people, if they're, for example, from the US, they already have the profile. It looks like something similar, something like that. Okay, so this one, the probe, it will be in here. Okay, and for this bit, actually there are not only one strand, I call it as a strand, one strand like this one, but in here there are many. Okay, so you can see from here, for example, this is the technology for the Illumina. I will show you later. Okay, so for example, in here, this is the bead I already told you before. And then this one is the strand of this probe. So there are many in here. This is about maybe 50,000 or something like that. Okay, so because there is information about identity of this probe, so when they are doing hybridization, in here they can go anywhere. And after some time, maybe there are, for example, resting in here. So wherever I go, they will know that this probe is about this gene or the representative of this gene. So it is not, you don't have to be worried. For example, this probe, you cannot identify, actually this is measuring about which kind of gene, because they're already been planted about something like identity in there. So it is very easy to understand that this one is this one, this gene, and this one is another gene, something like that. Okay. So both of Affymetrix and Illumina, they will provide you the raw data, which is based on image analysis or image processing. This raw data, then you have to do the pre-processing. So you have the sample in here. This is something that the sample or the tissue that you would like to investigate, and you are doing something in your lab, and then you are doing this microarray experiment in here. And then you got this in here is about the image from this chip or from this technology. And then you are doing in here is reading or scanning about this image processing, and then you will got the intensity. At the end, you will got the intensity, which is representing how much the gene actually expressed in this sample. Okay. So this one is for sequencing. Maybe we will talk about that later. So I would like to skip this one, but you can read it at home later. Okay. Okay, here. So you already have this data, and then this data is coming from many steps of preparation. For example, your sample, and also you are doing this image processing. So there are many steps which is contribute some error for this measurement of gene expressed or not expressed, or maybe how much expressed of the gene or how much not expressed of the gene as well. Okay, so because of that, you need to do the pre-processing, which is the step which is common for big data analysis. We can say that this is big data because there are many genes, which is about maybe 100 or maybe 50,000 genes for just in one chip, something like that. So the first one of pre-processing is background correction, and then you can do the normalization. If there is a perfect match and then mismatch, you can also do the step which is about PM correction. Usually this is coming from Epimetrics platform. And then after that, you can do summarization based on this summarization, and then you can have the value, which is intensity value, about the expression of this gene. Okay. Okay. There are some method for this doing pre-processing. For example, in background correction, there are some method which is about RMA, robust multi-array or robust multi-average, and also MAS5. And also there are some people, which is some researcher, which is prefer they are not doing background correction. If, for example, they are sure that there is nothing wrong in this background of this chip or this technology, okay? And then for normalization, the other method is quantile, VSN, and also sometimes they are not doing this one. And then for summarization, they are average difference, and then 2KB weight, and then median polish. Mostly they are using median polish in my knowledge, but some of them be there people like average different, that's okay as well. Okay. Okay. If you have already the data, it's probably coming from your microarray experiment, or maybe this data coming from the website, because there are many microarray data website, which is like NCBI or other thing. And then if you would like to see that from the point of view of statistician, or maybe from point of view of biologists, actually your data, which is the microarray data, after you read it, actually this is just something like this. So the raw, this is the information about the gene. For the gene, for example, there are 22,000 genes, so it will be the first gene until 22,000. And then for the column, it is about the sample. So the sample, which is we can see from like information, which is about how to say that the phenotypic of this sample. For example, the first sample is from female. For example, you would like to investigate about the cancer. For example, skin cancer. So the first sample coming from female, the second one female, the third one may be coming from male, and so on and so on. And also it is possible, not only the gender, maybe the age. The first one, for example, skin cancer from the patient about maybe 40 years old, or maybe some other maybe about 20 years old, and so on and so on. And also it is possible, for example, the stage of this cancer, the skin cancer may be the first stage, the second one, and the third one, and so on and so on. Okay, so that's information which is about the demographics information. We call it as phenotypic or pheno data. I think some company or some platform, they're already included. After, for example, there's a microarray experiment, and then they already included the information about this one in the file, and then you can read it later. Why this information need to be put when someone doing this microarray experiment? Because this is very important. For example, you would like to compare the gene which is expressed in male patient or in female patient, it is different, or it is actually similar, or maybe equal. Okay, if for example they are different type stage of cancer, we would like also to investigate which kind of gene actually express, for example, in the first stage of skin cancer, or in the second one and the third one, and so on. Why we need information like this? Because we would like to treat the patient accurately. If we have already information about this, so it is very important for the patient that they will get the treatment from, for example, hospital or from the expert. There are some option. For example, this option, the first option, we are dealing with this condition. So for example, we have to treat as like this. And the second one as well, something like that. Okay. When you are already having the data and you already doing the pre-processing, so the data already been ready to be analyzed. Okay, there are some statistical method. The first one maybe just something like, for example, you would like to have a description about this your data set. Okay, so you are doing statistical descriptive. Okay, and then if you would like to do something like doing the inference, and then you can also use statistical method in here. The first one may be something like how we call it, because in statistics we have something like call it univariate data analysis, or maybe multivariate data analysis. But also now I think they are already been introduced about another unconventional statistical method, for example, like data mining, machine learning, or maybe artificial intelligence. As long as we have the data, and then we can do the investigation, and then we can also take the conclusion based on statistical method data analysis. Okay. You can see from here, there are 10 statistical technique data scientists, which is really important. The first one is linear regression, and the other one also you can see there is a support vector machine. So support vector machine is one of the classification data analysis. And then also in here, tree-based method, it is also including in classification. And also you can see from here, like supervised and unsupervised. Supervised learning is mean you are doing classification. Unsupervised learning is mean you are doing clustering. Okay, so this one is important for you and also for me. So when we already have the data and we are already doing the pre-processing, and then we are ready to analyze this one. Okay, so have you got my R practice file in here?
I have shared with the participants now.
Okay. So let's have some practice in here related to microarray data analysis. So we just open our R or RStudio, it doesn't matter. I think I already sent the file which is about dataset1.r, right? Is that correct?
Yes.
Okay. Let's have this one. Actually, I have two dataset, two file. The first one is for the dataset already been provided in R, which is about ALL datasets. And then the second one, this is the data set which is coming from, in here I'm using NCBI. I am taking that from NCBI. So this is the data which is coming from public repository. So you have the experience letter that if we are using this data which is coming from R, already been provided in R, the way we are doing this analysis step by step is like this. But if we, for example, we have the new data set which is coming from public repository, so this is the step of base that you have to do, not only exactly, but at least the guidance, okay? Because maybe I would like to use supervised learning, and then you would like to use unsupervised learning. So of course it will be different, okay? So before I continue this one, I would like to make sure that you already install this bioconductor. Have you installed this bioconductor, please?
So the participants are muted. We should assume that they have installed R in the meantime, okay?
Okay, so do you have installed the R in your laptop or computer, please? If you don't have it, so you have to do the installation now. Maybe will take time a little bit, but later you can catch up because I already been provided the file, so you can just put that step one side, okay? So for but in my case, I already install. Okay, that's pretty good. Thank you very much. They already installed it, so we can just directly use this one. Oh, okay. Yeah. If you didn't install Bioconductor, but I can see from the chat box that actually you already been provided, or you already been installed it, so it's very good. So the first one is you need to install this library, this package. You need to call the library, I mean, but you have to install this package, which is about FE, and then this database about human genome. Okay, this is the first human genome database, I guess. And then there is a package all, which is ALL. And then you have to geostat. This is about gene ontology. I would like to introduce you from the beginning and then until differentially expressed gene. And then the last one may be about gene set enrichment. I hope I can explain that well to you. And then there is also Lima, this is very popular. And then for make your graphic beautiful. And then you need this R color board. If you don't want to use that one, that's fine as well, okay? Let me, can you see my screen, R screen or not yet? Maybe not.
Not yet.
Okay, I'm sorry. Okay. Now you can see this one in here. If you already install all of this, and then you can just call is library, which is something like this. Please let me know if you have any question. I would like to see this one. For bioconductor, RStudio is, yes, of course. No, I mean, before you are using bioconductor, you have to install R. Okay, and then if you want to use RStudio, you also need to install R. Why I'm using this RStudio is because of more convenient for me. But if you just want to use R, that's okay as well. Okay. There is a question from Nagiha. You are having this error. I think it's related to in Windows. I think you have to be an admin, right? Okay, if you are being an admin, and then you can how to say manage. What would you like to do in our installation? Yeah, I guess so. Cannot create director. Perhaps maybe because there is a question mark. Would you like maybe just use normal alphabet? For example, just like GLM. maybe. But I think if it is about unable to create something like this, actually you need the permission as an admin for your own computer. Okay. And then when we have to use supervised method or unsupervised method, okay. I would like to how to say, answer the question one by one. You are using supervised method when you would like to classify something, or in statistic terminology, actually, if you have the data, you will have something like dependent and independent data. If you are already having independent and dependent data, it means you use the supervised method. Okay, but if you don't have the dependent variable, and then you just use unsupervised method. Okay, if you only have variable but there is no hints or something like that, this is dependent or independent, so you just need to use the unsupervised. Okay, can we have RC? Yes, of course, I already sent it, don't worry. What manager to install now? What do you mean manager? I'm not sure about the question about this. Should we call all the library together before use? Okay, because I already know that I will use this library, that's why I asked you to call this library all. But in the real life, actually, you just need to call the library which is you need during your computation or during your analysis in Bioconductor, okay? I install R, not Bioconductor. Okay, the first one, you have to install R, and then you have to install Bioconductor. How to install Bioconductor, you can see from my screen, which is line 2 until 4. This is the way you install the Bioconductor, and then you directly install the core package of this Bioconductor. Is it possible to get data from geodatabase? Yes, it is possible. I would like to show you, and I would like to talk about this. There's something in my computer, and I don't know how to fix it, but I will tell you later. How to? Okay, we will use this one tomorrow. Okay, I hope we will use this Dataset package tomorrow. Okay, and then in case I want to get from the okay, I will show you here. Can you see my screen in here? You are using GEO query in here. So this is, you are using just get GEO and then so on. But fortunately, last week and last month, I used this for my other workshop. It is running perfectly well. But in here today, just today, in the morning, I guess, I couldn't figure out why this message is like this. I already tried to Googling something, and they said that this one exactly, I have to do this one, but I don't know how to do this one. I mean, I'm not sure how should I do. And I intend to ask someone at my university, which is knowledgeable about something like this. Maybe I will get back to you tomorrow, or maybe another time, if you have running the same problem as like mine. Kindly share your email address, ma'am. Yes, okay. I already mentioned my email address on my, how to say that, my presentation. You can see in there. How can I know if the package used here already installed? Okay, you just need to call the library. For example, you don't know, you already, but FE is the core package. So let's something like, for example, Lima. If you just put, for example, library Lima, let me call in here Lima, library Lima. Oh, sorry, I shouldn't using this one. So actually in, in how to say that, in RStudio, it is very convenient, just like this, run. Okay, if there is no message that error, no package of Lima, it means already been installed. But if it is not, how to say, if there is a message error about that one, it means you have to install it. Okay, just as easy as like that. I cannot see your screen. I think now you can see my screen. Okay. Okay, yeah, it is possible. In my console, I cannot install Acrobat. It said there's no package. Are you sure? No. Maybe you forgot about the apostrophe. Sometime if you forgot about the double apostrophe, it will give you something like that. Please try again. What library are we to install? This one. This not library to be installed, but the package. You have to install the package, and then when you would like to use it, you have to call by using this library. You have to call this library. Okay. Yeah, thank you. Yeah, if your R version is 4 point something, and then you have to use this Bioc Manager install. But if you are using R version below 3.6, so it is using Biox Lite. Biox, I will write it down later. There is no package called AFI. Have you do this one, Rafi? Number 2 until 4. Can you see my screen now? Okay. If you already done something like this, I'm sure because FE is something like how to say that core package. So it will be, if it is not in there, so you have to install it by yourself. So how to install it? Yeah, using this one. So in this case, I'm installing many package. Okay. But if you are only would like to install one package, so this is the way how you do that. The same this one like this. Let me show you. For example, you would like to install AFI, so it is just like this. And then enter. Okay. So, Putri Ardia, do you have any question? Package Bioconductor is not available for our versions. Are you sure you install the Bioconductor package? What I mean, you install the Bioconductor package, it means you are using number 2, line 2 until 4. Okay. And then, okay, thank you. There is no package, this one. No, there is. AGU 95 FE2 DB. Yes, there is. It means you have to install it. If there is an error like this, error in library, this one, there is no package call. This one, it means you have to install it. So how to install it? Please see line number 6. Can you see this one? Okay. Okay. In my case, because I'm using Mac laptop, it is not a problem, but I'm not sure in Windows, maybe yes. Yeah, probably yes. And then you have to delete it from the its library. You have to delete maybe from its library, and then you reinstall the new one maybe. All packages are available from RCRAN. No, my package here I'm using Bioconductor, not CRAN. If it is CRAN, it means just R package, not specific to Bioconductor for bioinformatics. Okay. Among these 5 package, really, okay. You actually you can post it your message, and then I can see the how to say that what's going on in your R actually in your laptop. In the console said that the package is available, but unable to update. Unable to update. If it is warning, not error, that's okay. Okay. Wine library has multiple package in it. No, wine library, one package. Is it fine if I download yeah, why not? But I'm not sure. It is the Bioconductor package, because most of the Bioconductor package already been how to say update to the current version. So I'm not sure it is suitable with the 3.0. Oh, I see. I'm sorry. Yeah, Bioconductor 3.0 is okay. So that will be the latest one. Okay. Okay. Is it fine? Yeah, it doesn't matter. Sufyan. Okay. I already sent it. Okay. Okay. We have to install or the package you call. Oh, tomorrow will be another thing. Do you want tomorrow will be the continuation of this? I'm not sure. I will be listening to Parvin later, okay? I mean, if you want tomorrow as well by continuing this topic, it doesn't matter for me. Multiple library, multiple package. Line 6 mean multiple package installation, okay. You show try download error with a URL. Try you can screenshot and then post it in here, and then I will give a comment about it. Okay, congratulations, Putri. I don't know. There is no packet. Oh, I see. Okay. I think before you directly Bioc Manager, if it is the first time, you have to go to number line 2 until 4, okay? In console, it's showing, we can talk about that later. Let me show you. Bandana, so that's okay. If there is no this database packet, it doesn't matter, okay? Yeah, Ramesh, I will do that later, okay? Okay, then. Okay, now I would like to explain line by line. The first one is, this is the first time I will install Bioconductor core package. So this is the way how I do this, line 2 until 4. But of course, you have to remove this hashtag, okay? You have to remove this one. I'm not remove this one. I didn't remove this one because I want to use it. I don't want to use it, but I would like to show you, okay? And then after that, because I need this package, and then I have to install it if I didn't install it yet. But because I already installed it before, so I just call its library, okay? So this one, the data set that we would like to use in this workshop. So you just call the data ALL. And then if you would like to know, let me show you. I will try to run with you. Okay. Okay. Yeah, can you see there, right? Now I would like to read the data which is already been in R in here. Okay, it means I already, the laptop, the computer are already been read it. And I would like to know the class of this ALL dataset here. So this is the expression set. Okay, and then if I would like to know what kind of expression set in this, I just type down ALL and I got this one. So this one is information. A little bit different if you are using just normal data, I mean just usual data, it will be in matrix, or maybe if it will be in data frame, or maybe in list, or maybe in array, something like that, okay? But this bioinformatics data, usually it is stored in expression set as like this, okay? And then after that, we would like to know, this is what I already told you about the phenotypic of this data set. You can see from here. Okay, so this one, summary of this phenotypic data of this ALL data set. The first one in here was C or D. I guess this is about maybe like how to say, identity of the data set. Then there is the diagnostics, and then this is gender, and then age, and so on and so on. So this is demographics variable. And then after that, if we would like to know about what kind of this data set A or LL in here in R, you just type as like this, question mark, and then ALL In RStudio, it is more convenient, so you just have to run like this. And then they will give you information in here, what actually this ALL, okay. Can you see on my screen as well? This one about acute lymphoblastic leukemia data from the REACH laboratory, and so on and so on. There is information in here. But if it is from public repository dataset, something like NCBI, they will give you different information. But because this is already been R, so it is convenient just to access about the information about this dataset by using this comment. And then after that, because you already know from here that all dataset, there is FAR label, COD, and so on. So this one is actually just to make sure you would like to know, you would like to engage more with this dataset. You can see there are information in here. It is about class, so it is about the data frame, the dimension. Why I need information about dimension? Because if it is too big, for example, 22,000, the row, and then, for example, for the column is about 50, so I couldn't access it, okay? But if it is only something like this, 128, probably is still okay for me. For my computer, I mean, and this one, you can see from here, it is not convenient as well, because actually I need something like this bigger. Sorry. Go back to there. Can see. So this one is my data set. So this one is, as I already told you, that it is something that information, maybe the code, and that is the diagnosis. This is the gender. So the first sample age, the first sample, he or she is 53-year-old, and this is male patient. And then this is the BT. There is information what is the BT in here about. You can read it from here as well. BT is mean the type and stage of the disease, okay? And so on and so on and so on, okay? Now for subsetting, you don't have to do this one. So we just need to go with just without hashtag in here. Now we just try to find out that our subtype, which is the data set that we would like to choose. This is ALL1, how to say, track AF4, okay? So you just need to do this one. Julia, for thermal control of your screen. Is it okay, Parvin, if someone would like to remote control of my screen? If it is okay, then I will be approved he or her request.
Yes.
It is okay?
Yeah.
Okay. Okay. And then this one, actually you already maybe learned from our session before. This is like that you would like to choose some kind of the data set that you would like maybe to investigate, or you would like to know more about that one, okay? So this one, let me just using this run. And then here, subsetting. I want to make sure this because the character, it has to be in character. And then now this one. And then for B cell, I would like to know more the information. That's why I'm using this comment. And this one, which is we would like doing subsetting. So we just want to know what kind of the information actually in this variable. Okay, you can see from there. And this one, this is about just subsetting. Remember, subsetting is mean you choose the data set or the information that you would like to investigate. Okay. Okay, to make sure that this is in factor. Okay, so that's perfect. You can see that in here negative, and then all one track AF1 and so on and so on and so on. Okay. So because you would like to do the pre-processing, the first one, if you have to remove the gene which is no interest gene ID. So this is another step when you are dealing with microarray data. How to do that? So the way you are doing that, but I'm not sure because some of you already told me that you cannot having this database. So probably if you didn't install Edge, GU95 and so on, maybe you cannot follow exactly as I already write on my file, okay? So just please make sure that you already been install all the package that we needed, okay? So this one in here, we try to see about the interest ID, okay, in our data set. And then in here, we try to check if we have already this one or not, okay? So when here, line 79, it means we try to check that there is no interest ID, which is already been removed before, okay? So, and after this one, okay. So because we already been having the interest ID, and then this interest ID has to be, how to say, has to be matched with the original data. So in here, we are using the command in line 81. You can see from here. So the last one here, this is the data set which already been removed, all the gene which is no interest ID. Okay. So the second one, because we would like to do the gene ontology, so we have also to remove gene which is without GO mapping. So how to do that? So in here we need this one. This is GO and anti-GO, okay? And then the way we are doing that, we are using S-apply. Have you learned about S-apply before? I guess you already learned S-apply in our session, okay? That's my assumption. Okay, so in this case, because I already been until line 82, so I just run this one. Okay, okay, okay. You will see the result later. Okay. So no GO, there are 208 gene without GO. Okay. In this case, we have this one.
Okay.
And then we got it like in here. So previously, we already learned that this one is not 11,000, but because of there are some gene without GO, that's why in here, which is about 208, and then it is reduced into 11,075. Okay, you can see the different maybe later, but now maybe you cannot see that one. Okay, so the next step is you are doing the non-specific filtering. Okay, what is the non-specific filtering? There are two kinds of filtering, non-specific and specific one. The specific one in Affymetrix platform or in microarray data analysis, in the chip, there are two kinds of probe. The first one is normal probe. The second one is control probe. This control probe, negative control probe, it has to be removed. So in this case, you are using specific filtering. If it is non-specific, it means, for example, you would like to remove the gene which is not expressed between two groups. For example, in here you have the group of BT, which is negative. There is ALL, which is negative, and also ALL1 / AF4. So there are two groups. If this gene, for example, not expressed between this group, so you would like to remove it. How do I know that this is, for example, not expressed? Maybe in here, for example, the how to say that? The variation among the sample between these two groups, they are not too high. For example, maybe about 0 point something, 0.4, or maybe 0.1. In that case, you need to remove the gene which is the variation is not much or not many. Okay, so in this case, I'm not using the variation, the variance, but I'm using the interquartile range. So in here, if the interquartile rank is, for example, less than 0.5, so I have to remove that gene. The way how I do that, you can follow this line, which is started from 97. Okay. So this one we can run like this. So line 100, it means you select the gene, which is the interquartile is greater than the cutoff. The cutoff is about 0.5. So because we already know about this one, so we have to put this result into our original, not original, the previous result. Because we already have the original, and then we the size of the gene is already been decreased by using the previous filtering. And then now we have also another filtering, which is not specific filtering. It reduce more. Okay. 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 This one, you don't have to do this if you don't want to, because this is about the chromosome. Because in here there is information in phenodata. The chromosome, Y chromosome is only 1 or 2, and another chromosome is not Y chromosome. Okay, so if you don't want to have this one, it doesn't matter. But if you want to follow this, you can do this. Okay, hello. It doesn't matter.
So
Okay.
I am muting all to stop this background noise.
That's okay. Maybe they are a little bit, but doesn't matter. Okay, the final result from this filtering, which is non-specific filtering, it is as like this in 112. You can see what kind of this data. Can see? This is the expression set, which is less than the previous one. Remember, the previous one is about 11,475 genes. But now we are doing non-specific filtering, and then it is reduced more. And then the result, which is the gene we would like to investigate, it is only about 4,000 genes. Okay, so in this case, it is really important you are doing pre-processing before you are doing analysis, because some of the gene, maybe it is just redundant. You don't need it actually. But if you are incorporate this gene into your analysis, it will not good. If you are doing modeling and then actually you already know that this gene actually nothing, it is not good for your model. Okay, so that's why you need to do filtering. This one, okay. Now I already told you here. Let me check in here. Okay. So in here you have already filtered by non-specific filtering your dataset. So you have to get going. Okay. Just call the library gene filter in here. Okay, this is about the duplicate. Okay. Let me do this one. Doesn't matter, just keep going. It doesn't matter. Yeah. Okay. Originally you have about 22 something gene, and then it is reduced to 11 something, and then it is reduced into 4,000 something, and then finally in here you have about 3,400 gene. Okay, so this is the way you are doing filtering. This color actually it is just for using in graph, so it is more convenient for me. But if you don't want to use it, it is okay as well. But we would like to use it here. So, okay, okay. Why we need this universe gene based on this specific filtering? Because sometimes if you would like to do the how to say gene set enrichment, you have to make sure that, for example, this one is coming from gene universe, or maybe alternate universe based on the chip just based on the chip. Okay, so it looks like if it is in calculus, you are doing global maximum, or maybe it is just local maximum. So in this case, if it is just entire the chip, it means just the local one. If you are using the universe, it means you are using the global one. Okay, so the choice, it is up to you. But if it is me, I would like to use the universe one. It is better. Okay, you want to check it. You have to check it to make sure that you already cover your gene in this one, already been covered in another one. Okay, so this one, wait a minute. Okay, if you already ensure that is the gene actually coming from the universe, or maybe just coming from the entire chips, so the next step is you are doing differentially expressed gene. So how you are doing that in bioconductor? The first one, because in here you would like to do differentially expressed gene, so you have to make the cutoff. You know, for example, this kind of sample, the first group and the second group will be different. If it is, for example, the difference between them is less than 5 or more than 5. Okay, so in this case, we are not using more than 5 or less than 5, but in here we are using about p-value. So in this case, p-value we are using is 0.05. If you want to use, for example, 0.01 or maybe 0.001 or maybe 0.0001, that's fine as well. Okay, I'm using the 0.05 just an example. So in here, because we know that we have only 2 groups, okay, remember in the previous one we have only 2 groups. So in here we are using t-test. If we have more than 2 groups, so you have to use ANOVA. So ANOVA in here, actually, they are calling it as F-test. So that's why you have to identify actually how many groups you would like to compare. You would like to do the differential expression between how many groups. If it is only 2 groups, and then you are using t-test. If it is more than 2, and then you are using F-test. Okay, or ANOVA, one-way ANOVA. So in here, the cutoff, it is 0.05, which is the p-value. And then in here, I'm using t-test. Okay, t-test value, and then the cutoff. Okay. Okay, so this is actually the differentially expressed gene, which is about only 667. You have to remember, previously it is about 3,400, but now it is only 667. So it is mean the differential expression, it is happen only in this 667. So how about the other one? The other one is not expressed, or the expression is equal or similar. Okay. So this 667, we can use it for further analysis. If, for example, it is between cancer, this is about lymphoblastic leukemia. And then in here we are using, I guess this is about ALL1 AF4 and then negative. So in this case, you are comparing 2 groups, both this leukemia lymphoblastic data. So based on this, the 660 something, we can say that maybe this is going for the first group, which is ALL1 track AF4, or maybe this is going for the negative one. So what is the negative? What is the ALL1? I think I'm not in capacity to talk about that. But if you are coming from biology or you are coming from medis, you know about that more than me. Okay. So in this case, you already select which one actually you would like to use. Okay. Okay, we already have identified this one. So because we already know about this entrance ID it means identity for the gene. And then we would like to know this gene actually related to which kind of gene ontology. There are three kinds of gene ontology. The first one is about molecular function. The second one is biological process. The third one is about cellular component. So this 667, actually this is belong to which one? If, for example, there are 5 genes which is not belong to these three gene ontology, it is possible. Maybe you are discovery this 5 gene which is related to this lymphoblastic leukemia data. Why we say that this is the discovery? Because no one already discovered about this one. So there is no record even in biological process or in molecular function or in cellular component. Maybe this is something new. Okay, or maybe this is nothing. How we are sure that this is nothing? Again, this one bioinformatics, you are working with data and you are working with computer. So to make sure, you have to go back to the lab. So you already have this 600 something gene, which is related to this 2 step of leukemia lymphoblastic disease. And then to make sure that this is really related, you have to go back to the wet lab, which is you are doing the experiment. If, for example, your experiment confirm that this 5 gene already I mentioned before, this is something new, and then you can do the publication. If, for example, this is nothing, maybe you can just quiet, okay? So this is the way how we are doing, how to say that, data analysis, which is about dry lab, just using the data, maybe other are doing the experiment about this microarray, and then we are doing the analysis. And then the confirmation about the result, our analysis, we have to go back to the lab. Ask someone coming from the lab, which is from biology or pharmacy or chemistry or maybe from medics, to do the experiment based on our finding. Okay. So again, we have to do the cutoff, which is I'm using the first one is 0.05, and now I'm using 0.00 something. So in this case, you are using this one. Okay. Just wait a little bit. Just wait a little bit. Okay, let me check the question. Maybe there's some question, I don't know. Okay, warning. Okay, or maybe it is probably you already, how to say, you already go to our version, which is more than mine. My version in here is, I think, 4.1 or 4.0. I'm not sure. I don't remember. 4.04 maybe. But if you already do the new version, maybe there are some package which is not updated by the owner or the maintainer, so they cannot perform well in the new version of art. It is possible, something like that. Okay. Permission deny. Again, I think if it is about permission, you cannot write. It is not writable. I think it because of you are not the admin of your own computer. So please ask someone maybe to check or to make sure that you are the owner or the admin of your own computer. I already shared the screen. Okay. Yeah, I think better. Bandana, you have to install the DB package as well. If it is not in there, but if it is already been there, so that's okay. I'm not getting in for this database actually, if for example, you are investigating about human genome, So you have to install the database of human genome. If you are, for example, investigate about mice, so you have to install the most musculus database, something like that. Okay. Is there any way to find this package? I guess you can go to Bioconductor website. There are information in there. You just need to scroll in the software, all in software, and then you can find the dataset. Okay, you can ask me, it doesn't matter. Ivan, yes, I already shared the script, okay? Ritwik, what kind of error, please? ROC, yeah, ROC, if you are doing, what is the name? Classification. Okay, if you are doing classification and then you need to understand about this ROC, because this ROC will produce the area under the curve, which is if it is close to 1, so your classification method or approach, I think it is very, very good. But if it is, for example, maybe 0.3, so your classification method you propose for the data, maybe it is not good. You have to do another, you have to choose or use another method or approach, okay? Okay. Is there a way I can view the dataset in a tabular form? Yes, you can. You need to save your dataset into CSV or TXT, something like that. You already learned about how to save your dataset into CSV or TXT, right? In the previous session, I guess, which is about our session. Yeah, there is no package called Avia, but you have the package which is called FE without A, just FE, not Avia. Object all not found because you have to install this library, this package, which is ALL package. How do I save into text or CSV format? You just need to write. You just need to type, right? Wait a minute. Right. This is autocorrect. If you are using CSV, so just write CSV and then which dataset. I have to write it which dataset, comma, and then the file name. I already write it down in our chat box, okay? Oh yeah, thank you. Write.csv. I'm sorry, thank you very much. We have reached the end of screen. I just returned uploading all the package. What did the mean, Joshua? I think everybody can see it because I share my, I'm sorry, I shouldn't do that, but I share in here, I share my screen so everybody can see that one. You just read everything all package. Oh, okay. You just need to do that step by step. It doesn't matter. If you would like to reach me after this session, it doesn't matter. I will be happy. We are doing that. Okay, so this one is the dataset which is already been in R, and it will be the same if you are doing that for the dataset which is not in R. So how to do that? I didn't share it with Parveen. I think I would like to share it with you now. Revise dataset for not document. Sorry, it has to be in download. In download, okay. I would like to share it with Parveen. Wait a minute. This one is for classification. You can use it. And then other one is for the dataset, which is coming from NCBI. And then you would like to do the same with the previous one, which is about differentially expressed gene, and also about, what is the name? I don't remember now. About gene set enrichment. Let me show you here. Data, okay. Okay, let's go back to our art session in here, Art Studio. Okay, in here for the data set 2, okay, I use a lot of things in here, but actually you don't have to. But if you would like to work in Bioconductor, which is in R, if you don't use it now, maybe you can use it later. So if you are install it now, it will be fine for you. This one, I would like to use this GSE 10072, which is from NCBI. Let me show you this NCBI. Maybe this one. Okay, GSE 10072. Okay, this one. Okay, you can see this is about expression profiling by array. So it is about Affymetrix. And then this is organism is Homo sapien. And then this one, previously you are using human genome U95A version 2nd. But in here you are using Affymetrix human genome U133A array. So in this case, you need to use AGU 133A database, or maybe CDF as well. Let's go back to RStudio. You can see from here. Okay, can you see the line number 10, which is AGU something like this, which is the database, and this one you need the CDF. If you already have this one, CDF mean what is C? I don't remember. DF is mean data frame, but I don't remember what is C in CDF. I will tell you later, but now I really forgot it. So you really need this information, because this will give you. You haven't received the dataset, so okay. Parvin, I think he will send you later.
I will send now. Okay, there is no
issue. He already sent it now. Okay, thank you very much. And then this CDF is very important. Why? Because this is about the information about the data which is coming from the chip. For example, this location may be about this probe, and this probe or probe set, maybe it is about measuring some other gene from, for example, maybe the first gene, and then another one maybe the second gene, and so on and so on. Okay, so let's go back to the NCBI dataset, and then based on this one, which is about gene expression, cigarette smoking, and its role in lung adenoma, and so on and so on. So in here, if you are seeing the dataset, there are about 107 sample, which is patient. Okay, and some of them they have lung tumor. They don't have lung tumor, which is just normal lung tumor. So you can see that actually this is, there are two groups, normal and then lung tumor. And then for this lung tumor, I think they are different stage as well. We can see that later. But unfortunately, as I already told you before, when I try to do that in R, let me show you here. The way you are doing that in R, if you would like to do the analysis of this data set, first, you can just, how to say that? You can just download it and put it in your laptop, save it in your laptop. And then, for example, in one particular folder. And then after that, you can access it by using R command. The second one, you can use this one, GEO query. It is directly read it from the website. So for this one, I am already successful using this dataset. Where is the GEO query? I couldn't see that in here. I don't use it in here for GEO query, but actually this is the same. This one. This one. So the first one but that's not the same dataset, but it is the step by step it is equal. So this one I already downloaded and put it into my file, which is I'm using this June 26 folder. Okay. And then in here, I already get information about this data. So let's start running this code. Okay. 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 So this one about 76 sample. The previous one it was 100. This is the different sample or data set, but that's okay. So after this, because I don't know what is inside this data set, so I'm using this read FE, which is for FE metrics platform. And then in here, later I will show you, this is about FE batch. In this FE batch, because previously in the first data set, we are using expression set. So how to get expression set from this FE batch, I will show you later. So this one, you can see that this one is about FE batch object. So if you are using or you are taking the data from NCBI, which is public repository, it must be your data set in FE batch. If it is coming from FE metric, if it is Illumina, maybe different thing, okay? And then after that, because you are dealing with expression set, so how can I get this expression set? This one can use this comment, which is from library GEO. We are using this get GEO, directly run. If everything okay, I hope in your computer everything is okay. You can see everything is okay in here, but this one, I'm not sure why it's like this. Maybe someone in here can point it out something to me, but I couldn't figure out. Maybe I will come tomorrow, as I told you, to my colleague to solve the problem. In June and also last week, I still used the GEO and nothing happened. Still okay. So I can directly access the data. But I'm sure if you don't have the same problem as like mine, your comment or your script, my script, if you are using it in your computer, it will be okay for you. So please get back to me later. And then if you already have this data set by using this GEO comment, and then you will have this gene expression. How to get this gene expression? By using comment 25 and also 26. In this 26, actually you directly get the data in like column and row. So in this case, you can, somebody already asked me how to save this in CSV format. You can directly use that one, and you can directly also save the data which is in CSV format. Okay, and after that, why I'm doing this box plot? Because I would like to know before the pre-processing and after the processing, is there any difference or not? If you think that it is not important, you just keep it. It doesn't matter. I cannot use it now as because I couldn't download this data directly. So we will do it maybe later. And then this one is the panel data, because previously when you already have expression set, and then you can see the panel data of your data set. It is very important if you would like to use, if you would like to do the differential expression or gene set enrichment. And this one, it is just try to take a look the panel data. This one we just choose some of the data set. Okay, we choose why. Maybe we already know, for example, this sample is not good, so we don't use that one. So we directly just remove the data set, okay, or the sample. This is just another information, so you don't have to do that. That's okay. Okay, Doesn't matter. Okay, now here, you are doing the pre-processing. In this case, I already mentioned in my presentation that for pre-processing, there is background correction, and then there is normalization, and the last one, it is summarization. So in this case, for background correction, I'm using RMA. Okay, so in here you are using RMA, and then for normalization, I'm using quantile, and then for summarization method, I'm using median polish. So can I use another method for background, normal, and summary method? Yes, you can. You can choose as you like. But actually, this method, this is the method that actually other people prefer to use it when they are doing bioinformatics analysis by using this bioconductor. Okay, so this one, it is just an expression value. Expression value is mean the intensity of this gene. Okay, so this one, I already told you that before and after pre-processing, we would like to know there is different or not. If you think it is not important, you can just skip it. Okay, after that, you are doing filtering, the same like before. You can see that the filtering in here, I am using the variant. It has the variant function, which is about the interquality range. And then the variance cutoff, it is 0.5. It is less than 0.5, so the gene will be directly discarded. Okay. This one feature actually FFX. This kind of information, which is FFX, is mean I already told you that in Affymetrix platform, there are two kind of probe. The first one is normal probe. The second one is not normal. Not normal is mean the control probe. And then this control probe, there is negative control probe. There is positive control, but all of them, both of them are control. So this control probe, it is not useful when you are doing analysis. So after pre-processing, you have to remove it. So how you can identify that this kind of control probe already been removed? This one, Affymetrix already identify or give you a hint that if it is control probe, and then you will have this one at the end of the name of this probe. It is containing this this alphabet. Okay, so that's why in here we exclude the gene or feature which is containing AFFX. And then for duplicate, we already learned as well that if it is the entrance ID, it is duplicate, there is duplication. It is also need to be removed. If you don't remove it, it will make you a little bit giving you headache. Actually, this measure about this gene, or actually this probe is measured another gene. So that's why we need to remove this one. Okay. Maybe you have question why this duplication entrance ID is happen, because it is normal. The company, they produce it, and maybe in some production there are some operator maybe for example not really pay attention, and then the error happen, and then the duplication happen. Okay. This one, okay, so we already doing filtering in here. So this one is the filtering result already been in expression set. In here, you can see that you can get back to me later. And then, okay, so this one, if you are doing classification, so you have to identify, for example, this one is the first group, the second one, the third, and so on and so on. But also, this is important if you are doing classification, there is step which is about feature extraction. So this feature extraction actually the same differential expression in statistical point of view. Okay, so you are doing feature selection or feature extraction. It means you are doing differential expression. Okay, in here you can see that there are 4 groups. So when you are doing a feature selection, which is which gene actually will be further analyzed, or which gene actually should be removed from this analysis. So you can see from here that because there are 4, okay, 4 groups. So in here you are using test equal to F. I already mentioned to you, if the group is more than 2, and then you have to do ANOVA one way, and ANOVA one way in bioconductor, which is in here, you are using test F test. If it is only 2, and then maybe in here, test equal to T. Okay, so there are different thing, there are different kind of way how to do the T test. If you are using this library, this package, which is Maltese, so you are just using this command, which is about empty t-stat. But if you are using different thing, which is about filtering, I guess you are using t-test something. I already showed you before. But both of them actually they are doing the same thing. It because of this package, it is developed by other expert, and another package is developed by another expert. So they prefer maybe using this this way how to do the analysis, or how to do, for example, differential expression. It's okay. Okay. When you are already removed this one, the gene, which is filtering, which is you are doing filtering for the gene which is not expressed, you can use the p-value, as I already told you before. And this case, so if you're already doing this kind of filtering, and after that you can do the data analysis, because in here I would like to do the classification. So in here you are doing classification, as I already mentioned in here. Okay, for this classification, actually in statistic data analysis, for doing classification, the row should be the object. Okay, and then the column should be the variable. But in bioinformatics data, the variable actually in the row, which is the gene, and then the object, which is the sample, it is in column. So in this case, if you are already doing filtering, you are already doing pre-processing, and then you are doing already other thing, so you have to transpose your data set. So that's the way how you are doing classification in bioinformatics data analysis by using bioconductor. So you have to transpose. It looks like the matrix, column being row, and then row being column. Okay, so that's why in here I told you that we are doing preparing for data classification. I mentioned also before that classification, it means you already know about the dependent variable. So in here, the dependent variable, I'm using the variable in here is y. Okay, so y, it is equal to data fact. Data fact, it means data vector, vector which means different, how to say, classification. 1, 2, 3, 4, in here is until 4. You can see from the previous one, I guess. Okay. Okay. Because you are doing classification, for classification, you have to do the step about training and learning, training and test data sets. So you have to divide your data into training and testing data set. Okay, in this case, mostly people using 80% for training data set, which is to build the model. And then you are using the testing of your model by using 20% of them. You can see from here, I'm using 80% for the training data set. And then the rest will be 20%. It is for testing, my testing data set. Okay. Yeah, the rest, I think you just choose the best parameter. Okay, after you are choosing the best parameter, because we are in here, we are using SPM for the classification. And then you have to validate, cross validation of your result. If, for example, your cross validation is greater than 75 or at least 75, it means your classification is okay, still good. Okay. If, for example, your cross validation or your accuracy, it is greater than 90%, so it means congratulations. If you are proposing the new method or the new approach or the new algorithm, so it means your algorithm may be probably the best, or maybe just mediocre, or maybe you have to improve your how to say, your proposed algorithm. Okay, I couldn't show you how this is done because of, I told you I don't have my data, so that's why I guess I have to show you another time. Okay, do you have any question? Please let me know. for the second data set in here, the same I couldn't show you, but this is the step-by-step similar to the previous data set, which is data set 1. But for data set 2, I'm using public's data set. So you can see, yeah, we need to remove gene that have no interest gene ID and so on. Remove gene with no GO mapping. I already also in here. Non-specific filtering also I already mentioned in here. Okay, and then the last data in here. This is not until how to say the gene ontology or gene set enrichment. But if you follow the previous one, which is data set 1, you can understand what to do next. Okay. I guess that's one. Yeah. Okay. Object is column and gene is a row in data. Yeah, that's in data set for bioinformatics data. But if you would like to do classification or if you would like to do clustering, you need to transpose that data set. Another platform, it is about Illumina platform. I used it before, but now I didn't use it. But if you would like to have discussion, we can have discussion later. Okay. Thank you, Alberto. This is about the data set. Okay, Jason, Alberto already show you how to. Okay, how to download it. Oh, wait a minute. Okay. If you would like to download it, you are using, can you see on the screen, there is GSE, for example, GSE 10072. You need to choose this one and then use this HTTP. Okay. If you already downloaded, and I would like to show you the results, this one, directly in the folder. And the folder, this is containing this cell, which is in zip file, zip file. Okay. So because this is 10072, so in here there are 107 data set, which is about sample. Okay. You can download as well a series matrix file in here. From here, you can get information about PENO data. But the same, if you are using this GEO query, which is coming from GEO query, get GEO, and then in my computer, the same thing will happen. But I'm not sure, maybe in your computer or in your laptop, it will be successful. If it is successful, it will be good. You can tell me, and then you can tell other participant as well that everything is okay. If it is, for example, downloaded is okay, and then reading using getGeo is okay. But I have, for example, stumble in line something, you can tell me. Okay. No, CDF is not cumulative DF. Let me show you later. Okay. I'm sorry. Really? Yeah, this is not executable. If you would like to share your screen, I can give you my feedback. Couldn't view the file. If you cannot see your file, I guess it's already been saved in the how to say that, the working directory of your R. So you have to make sure where your working directory. For example, my working directory is I just need to use this. So my working directory is user lab statistic 11. you can do the same, and then the R will or R Studio will show you where is working directory. If it's already been shown in your laptop, and then write.csv, you can try to find it in your working directory. I'm sure it will be there. Is it only no, there is BioPython. I already told you in the beginning that there is another one, which is Python. They have instead of Bioconductor, they have BioPython. How do view the file? You just click on the file, I guess. R package no copy with my install are okay. Actually, some of them compatible, but because of they already update, so maybe it is not compatible anymore. So I think you have to upgrade your R. Once you already upgrade your R, and then I'm sure the other one will be okay. Oh, okay. So everyone, I'm really sorry that how to say that this is not working for the public repository dataset. But if you would like to show me tomorrow or maybe another time, or maybe after I finish it, my laptop, so I can show you that how it is going actually. But previously, I can guarantee this is working. Because of just this one, I'm not sure why today. Last week still okay, but today is not okay. I'm really sorry about that one. But you can try in your computer. If you are using Windows, maybe that's better. Okay, or it is, if it is, the problem is about RStudio, if you are doing that the same as like me, it will not be going as well. Okay. Okay, I guess for today is that's all from me. If you still have any question, I can answer your question. If you want tomorrow continuing this one, it will be okay for me. But I have to, how to say, I have to discuss it with Parveen.
Okay.
Yeah.
So thanks, madam, for such a nice and wonderful marathon session. And tomorrow again, Dr. Rohamadal will with us at the same time. So we will meet again tomorrow at the same time.
Okay.
So I think most of the questions are over, and you addressed the question wonderfully. We are honored that you delivered on our platform, and I am going through the chat box. All people are saying thank you for such a great explanations. So
okay, thank you.
So I have already shared the material and data sets with the participants, and hope these people are enjoy learning with you. So with these words, now I seek your permission for ending today's session.
Okay. Thank you very much. Bye-bye.
And thank you, and we will meet again at the same time tomorrow with a fresh session with Dr. Rohmatal. Thanks.
Thank you.